Hello guys and gals, it is me, Max, from Ace's Biochemistry course, here to overview and explain my last video, The Basics of Biochemistry, Episode 1. Explained is a separate series where I explain some more tricky subjects from the previous episode. Today I will cover the theme of all atoms, a deeper insight on the periodic table, and other small things not covered in the last episode. So, as we learnt, this is a covalent bond. Quite obviously, this representation is not representative of what a covalent bond looks like in real life, because they are not actual tangible things, and pretty much a theory. Now onto the periodic table. Remember where actinides and lanthanide go, by the way? Each chemical has a valency. This periodic table doesn't show it that well, so let's change that. Here we go. The numbers at the top are the valencies of the below numbers. Transition metals always should have a Roman numeral from 1, which is I, to 3, which is III, which indicates its valency. The valency is how many electrons it needs until the outer shell has 4 or 8 electrons, where 8 is the highest amount the outer shell can have. It is an important factor in many reactions on determining what compounds are formed. I think we're comfortable with this, but always remember 2n squared at the outer for a certain shell's amount of electrons. This does not apply to the outer shell though, which it will always be 8. I believe we are already sound with covalent bonds by now, and don't need to explain this again, but anyways, here's a quick recap. If two or more atoms wish to bond, they have to share valence electrons, and to do so they have to form a covalent bond. Covalence is pretty obvious to what it means. Co, as in together, or in this case sharing, and valent, as in something to do with valence electrons. Now on to noble gases. Remember I said noble gases cannot bond? Well, why can't they bond? Well, that's because they have a full outer shell of electrons, but as we know previously, covalent bonds are the sharing of electrons, but as no element has 0 electrons, you cannot overload the outer shell with over 8 electrons, so therefore they cannot bond. I'm pretty sure that you are all clear on why biochemistry periodic table is better than the traditional one. But what do these symbols mean? H, C, Ca, what do they mean? Well, skip this part if you already know what they mean, but if you don't or you need recapping, H is for hydrogen, B is for boron, C is for carbon, N is for nitrogen, O is for oxygen, F is for fluorine, Na is for sodium, Mg is for magnesium, Al is for aluminium, Si is for silicon, P is for as I said in the last episode, shaping chemistry is a topic for another episode. But thank you guys and gals, I'll see you